For Finance Core, Topic 5, NPV and IRR, Learning Objective number 4. We're going to compute EAC, equivalent annual cost, and understand how it's used to evaluate projects. So the example we're going to use is a very simple one. Suppose I need to buy a light bulb. I can buy a traditional, cheap, incandescent light bulb for $1, or I can buy, say, this expensive fluorescent light bulb for just, say, $5. Now the difference is this one is going to last maybe about 4 months, where this one's going to last about 40 months. So it's a much longer lifespan. And what you're going to find out is that NPV can't really handle investment decisions when the lifespans are different and these projects are mutually exclusive. In other words, I can't put both light bulbs in. I have to choose incandescent or fluorescent. They're mutually exclusive investments. And NPV is actually going to give me the wrong answer in this example. Also to make things more interesting, the amount of light in a 100-watt light bulb is, first of all, it requires 100 watts, so it's much more electricity. For the same amount of light for this one, I only need 15 watts. So I only need 15% electricity to run this light bulb. So let's run the numbers and see what NPV does. And by the way, we're going to calculate something called equivalent annual cost using the NPV number. And even though it's called equivalent annual cost, EAC, we're going to do it in monthly terms for this example. So there we go. Let's go to the spreadsheet. I think I mentioned everything. The only thing I haven't mentioned is I want to use a discount rate of 8%. That's the rate of return I require for buying a light bulb. So you don't need to have the details here, which are over here, but basically I have a 100-watt light bulb, incandescent light bulb. It costs $1 and it has and lasts for 4 months. And I have a 15-watt, $5 fluorescent bulb that has the same amount of light, the same amount of lumens. However, it's going to last 40 months. So here's the cash flows. I'm going to spend $1 today for the incandescent light bulb, and the electricity cost turns out to be $3 a month, assuming 8 hours or so a day. Or I buy the $5 light bulb, the fluorescent one. It uses only 15% of the electricity, 45 cents a month, and it lasts for 40 months. So which one do I choose? Well, if I use my NPV analysis, NPV, use my 8% discount rate divided by 12 for the monthly discount rate, and then I put in the monthly cash flows from years 1 through 4, or 1 through 40, and then add back today's cash flow. The NPV of the incandescent light bulb is $12. The NPV of the expensive fluorescent one is $20. So you might say, well, the best deal, if you're trying to minimize the NPV of costs, the best deal is to get the incandescent. However, you see it doesn't really make sense because this one is 40 months and this one's 4 months. So here's what we do to solve this problem. Using mutually exclusive projects, we have to choose, say, project A over project B. Can't do both. And what you're going to do is you're going to convert the cost to a monthly cost. So notice I have a payment function here. The payment function uses the discount rate I used, and this is a monthly discount rate, so 8% divided by 12, for 4 periods. And where it says PV, I put the net present value of the project. So what this is going to do is going to convert the NPV to a monthly payment of $3.25. And then I copy the same formula, and it's going to convert this NPV of $20 spread over 40 months. That's the only difference here. I had to change this to 40 instead of 4. So including the cost of the light bulb and including the lifespan and the future costs, the monthly cost of a fluorescent light bulb is 59 cents, even accounting for the fact that it costs 5 times more. So it's quite clear I want to do the fluorescent light bulb. So that is EAC. When you have mutually exclusive projects where you do A or B and they have different lifespans, what you're going to do, you're going to convert those into payments, or you use the payment function, use the NPV of the project as the present value in the payment function, And then as far as the number of payments, you put in the life of the project, say 4 months or 40 months. And then you just compute the equivalent payment. So in that example, we just computed EAC.